Push that rock here with Simpson math. Let's solve some equations with radicals in them, specifically square roots, okay? So here we have a fairly simple equation, but it has this square root in the middle of it, and we want to be able to solve this equation. So what we're going to do is do our best to isolate this radical. We're going to get it by itself. So to get that by itself, what we would do is subtract a 5 from both sides. So I'll subtract 5. That's going to give me this radical equals, this is gone, so on this side it's not there anymore, and over here we get x minus 2. And now what I'm going to do to get rid of the square root, I do the operation that will eliminate it, which is the square. So I'm going to take both sides and square. Now that means over here I have a binomial times itself, x minus 2 times x minus 2. And we know enough now to know that if you multiply a linear by a linear, you get a quadratic. So I get x squared, negative 2x, negative 2x, negative 2 times negative 2 is a positive 4. So this simplified quadratic is x squared minus 4x plus 4. But what's happening on the left? I've been spending the whole time on the right over there. Is that in the screen? Yeah. So, well, this square undoes the square root, and I just have 3x plus 4. So this is 3x plus 4. I haven't done anything. Okay, but we have a quadratic. So we want it to be equal to 0. Our strategy is to, when we solve a quadratic, is to have one side 0. So I'll subtract the 4 from both sides. Oh, it goes away on both sides. That's nice. And I have 3x is equal to x squared minus 4x. Now I'll subtract the 3x from both sides. See, that's gone. And I have 0 is equal to x squared minus 7x. And so we could use quadratic formula, but notice our c is missing, so this is easy to factor. We could factor out the greatest common factor. Oh, that was a really bad 7 I wrote there. Let me correct that. That's a negative 4 minus 3 is a negative 7. Okay, when I take negative 4x and I back up 3, I'm going to be at negative 7x there. But when I factor out the common factor x, I have x minus 7 here. X times x is x squared. X times a negative 7 is a negative 7x. So I factor out the common factor, and we've got two numbers. One of them is x, and the other one is x minus 7, and they're multiplied together and they equal 0. That means one of the two numbers, to make this a true statement, one of these two numbers has to be 0. Either the x is 0 or the x minus 7 is 0. But if the x minus 7 is 0, then x must be 7, because 7 minus 7 is 0. So we say x minus 7 is equal to 0, but then we see if we add this 7 over, x is 7. So we have two solutions, but they might not actually be solutions. When you square both sides of an equation, you introduce what's called an extraneous root. An extraneous root is one that works maybe in one step of the equation, like maybe it works here. Like if I put a 0 here and a 0 here, this is clearly a true statement, but it might not work in the original. If it works in one of the equations but doesn't work in the original equation that you were given, it's called extraneous. So let's check our two solutions. So our equation was the square root of 3x plus 4 plus 5 is equal to x plus 3. And one of the solutions we want to check is x equals 0. Can we see it? Yeah. X equals 0 is one of our solutions. So I'm going to take that x equals 0, and we're going to check x equals 0. That means everywhere I see x, I'm going to put in a 0 and see if I get a true statement. So I have 3 times 0 plus 4 plus 5 is equal to 0 plus 3. Well, this goes away, so the square root of 4 plus 5 is equal to 3. Well, this is not true. 2 plus 5 does not equal 3. So 0 is extraneous. It worked in this equation, if I put in 0, it will be equal to 0. But it does not work in the original. That makes it extraneous. This one we will check next. So going back, I'm going to check, x equals 7. Can we see that? Okay, yeah. We're going to check x equals 7. Our original equation was 3x plus 4 plus 5 equals x plus 3. And we're going to plug in a 7 there and there because I'm checking x equals 7 now. So I have the square root of 3 times 7 plus 4 plus 5 is equal to 7 plus 3. Over here we get 10. Here we have the square root of 21, because 3 times 7 is 21, plus 4 plus 5. Well, 21 plus 4 is the square root of 25. I can see this is going to work because the square root of 25 is 5, and 5 plus 5 is 10. That one checks. So x equals 7 did check. That's our solution. This is an extraneous root. It's not a solution to the equation we were trying to solve. And that's how you solve simple equations with square roots in them. Math made simple, Simpson Math.